this video is covering 11E notes, solving rational equations. This entire unit we've been simplifying rational expressions, but now we're actually going to solve equations involving rational expressions. So when we solve an equation, we need to simplify both sides before we can solve. And also with rational equations, what we like to do is we like to clear the fraction. So when we have rational expressions, we have fractions. And when we're solving, it's nice to clear out those fractions so that we have a nice, much easier equation to solve. So in order to clear those fractions, the first step that we're going to take is to find the LCD of the equation. Now that's the whole equation. So both sides of the equation are we're going to look at. So we're going to look at every single term. Then we're going to multiply the entire equation by the LCD. What happens here is this is going to clear out the fractions, or it should. So if it doesn't, that means you probably did something wrong. Then we're going to simplify each side of the equation and then solve. Now, we know two ways to solve. If you get an x squared term, you're going to solve by setting the equation equal to 0. Because if you have an x squared, that means quadratic. So you want to set it equal to 0 and factor to solve. If there are only x terms, that is no x squared terms, we're going to isolate the x, solve for the x like normal. Okay, so in this first example, the first step is to find the LCD of every single term. So our denominators are 3x and x. So the LCD of 3x and x, so is going to be the 3x. It's not 3x squared, it's just 3x. Because the 3 over x and the 2 over x already have an x, they don't need an extra x under there. Okay, so the LCD is just combining things that they don't have in common. All right, so the LCD is 3x, so then what you want to do is multiply this whole equation by 3x. So what that'll look like is that 3x will multiply by the first term, 1/3. So we're going to be distributing that 3x to all three terms. Then plus the 3x times the next term, which is 3 over x. And then that will equal 3x times our last term, which is 2 over x. Now, remember that this is your equation, so you can't just combine all of these terms together. The second step is you want to simplify. All right, so 3x times 1/3, the 3's cancel, and you're left with x times 1, which is x. Plus 3x times 3 over x, the x's cancel, leaving you with 3 times 3, which is 9. Then equals, on our last one, the x's cancel, leaving us with 3 times 2, which is 6. Now we have a very easy equation to solve, so all you have to do is subtract 9 from both sides, letting you have the answer x equals -3. Okay, so first up LCD, multiply through by the LCD, then simplify and solve. Okay, so let's try another example. So part B. In B, let's look at our denominators, 12, 2x, and 3x. So our LCD is going to be, when I look at 12, 2, and 3, the least common multiple is 12. And then I have x and x, so x is going to be part of that LCD as well. Okay, so now I'm going to multiply through by that LCD of 12x. Now, for this one, I'm going to kind of do a little bit more in my head, so if that's too complicated for you, then you can write it out like I did in example A. So what I'm going to do when I distribute is kind of think in your head. So 12x times 5 over 12. What's going to happen is those 12s are going to cancel, and then you're left with the x times 5, so you have 5x. Then I have 12x times 1 over 2x, and that's a negative. So when I divide that, what's going to happen is the 12 is going to divide by the 2 to become 6, and then you have an x in the numerator and the x in the denominator, so the x's cancel. Then for the last one, we have 12x times 1 over 3x. So when you multiply that, that gives you 12 divided by 3 is 4, and then also the x's will cancel. All right, so now you can solve for x. So I'm going to add 6 first. So I have 5x equals 10, divide by 2, and x equals, I'm sorry, divide by 5, so x equals 2. Okay, now for example 2. So in example 2, we have rational equations, but notice that there's no adding or subtracting. So when we look at example 1, you see that I have 1/3 plus 3 over x. In B, I had 5/12 minus 1 over 2x. Okay, so I had to multiply through by the LCD. However, if you look at example 2, A and B, those are not adding or subtracting rational expressions. So what actually you have in A and B is called a proportion. So that's very similar to what you saw perhaps in middle school, like x over 10 equals 2 over 5, something like that. So then you would cross multiply to solve for the x. So what these are proportions. So we're going to cross multiply. But you can only do that if you're not like adding or subtracting another rational expression. Okay, so when I cross multiply, we have 1 times 8 is 8, so that's on one side of the equation. And then be careful now that you have expressions, you have to make sure you think of this x minus 2 as a binomial in parentheses. So that x minus 2 gets multiplied with x, and that x has to distribute. So now we have 8 equals x squared minus 2x. Now, remember in my notes that when you're solving and you have an x squared, that is a quadratic, and you have to set this equal to 0. So I'm going to subtract 8, and now I have 0 equals x squared minus 2x minus 8. So now we're going to factor this. So 8, the factors of 8 are 2 and 4, and when those subtract, that will make -2 if 4 is negative. So then x is equal to +4 and -2. Okay, so now let's try example 2b. So again, I have just a proportion, so no adding or subtracting rationals. So I can cross multiply. So now again, think of this x plus 1 and this x plus 2 in parentheses. So we'll have 4 times x plus 1 equaling 3 times x plus 2. So then when I distribute, you get 4x plus 4 equals 3x plus 6. Now notice there's no squareds, so that means I want to isolate my x value. So I'm going to do that by, I'm going to subtract 3x, and then I'm also wanting to subtract 4 at the same time. Okay, so then 4x minus 3x is x, the 4's cross out, 3's x's cross out, and then 6 minus 4 is 2. Okay, so typically if you have just an x, no x squared, you'll get one answer, and x squareds will get 2 answers most of the time. All right, so example 3. So now notice we cannot cross multiply here because you're adding this 1 here. If that 1 was not there, then you could cross multiply. And you cannot just subtract 1 from both sides because then you'd have the -1 on the other side. So you're going to have to do what we did in the first example, which is find the LCD. So I'm going to find the LCD of the whole equation. Now notice that the LCD, so 1 can be written as like 1 over 1. So the LCD there is just 1. We don't have to think about that. So when we're looking for an LCD, you want to factor your denominators. So this part A does have a denominator you can factor, which will be 3 times c plus 4. And so now notice, just like when we were adding and subtracting, notice that they both have a c plus 4 in common. So the LCD is going to be that c plus 4, and then also that 3 from the first expression. All right, so now I'm going to multiply through by my LCD of 3 times c plus 4. Okay, now if you need to write this out, I'm going to write this one out so you can see what happens. So what that means is I'm going to take that 3 times c plus 4 and I'm going to distribute it to everything. So I have 3 times c plus 4 times 4. Okay, that's the first term, and that first term is being divided by 3 times c plus 4. Okay, then plus the 1 gets multiplied by a 3 times c plus 4. And then finally, we have the 2c is multiplied by 3 times c plus 4. Okay, so what I have in black are what was with the original equation. Okay, and also I'm not changing the denominator. You're going to see what happens when I do this. Okay, all right, so what happens is when I multiply through by that LCD, you can see that all my fractions get cleared. Because looking at the first example, when I multiply by that 3 times c plus 4, those 3 and c plus 4 are going to cancel. The middle term had nothing to cancel, and then the last term had the c plus 4s to cancel. Okay, so typically when I'm doing this, I skip this middle step here and go straight to my next line. Okay, because when I multiply that first term already has the LCD. So that's going to cancel out when you multiply by the LCD, leaving you just with a 4. Then the next term does not have a denominator, so when I multiply by the LCD, it's just normal. So I'm going to multiply by 3 times c plus 4 times 1, so that does not change it. Then in the last one has the c plus 4 in common. So what I'm really going to be multiplying the numerator by is the 3. So then when you multiply 3 times the numerator, you'll get 3 times 2c, which is 6c. So next example, I'll do that the kind of shortcut way. So now I'm going to distribute. So I have 4 plus 3c plus 12 equals 6c. And then simplify. 4 plus 12 is 16. So now to solve for c, I'm going to subtract 3c on both sides. So that gives me 16 equals 3c. Divide by 3, and you get that c is equal to 16 thirds. Okay? So now for the next example, what I'm going to do is I'm going to kind of skip that middle step there and show you how to do this without having to write all that out. Okay, for example 3b, we have our denominator of x minus 1, which does not factor, and then I have a denominator of 1, and then I have x squared minus 1, which does factor into x minus 1 times x plus 1. So notice I already have the x minus 1 in the first term, so my LCD is going to be x minus 1 times x plus 1. Okay, so another way that you could think of this is kind of like when we were adding and subtracting with unlike denominators. So this x minus 1 here is missing the x plus 1. So I'm going to multiply that numerator of 3 times the x plus 1. Then plus the single 1 here does not have a denominator, so it's missing the entire LCD. So that's going to be multiplied by x minus 1 times x plus 1. And then finally, the 12 has the entire LCD. So when you multiply through by that LCD, then those are going to completely cancel, leaving you just with 12. So now we've cleared the fractions. Okay, and now we want to simplify. So the first one, you get 3x plus 3. Then in the second one, remember this was the difference of squares, x squared minus 1. So that's just going to be plus x squared minus 1 equals 12. Notice we have an x squared, so that means we're going to want to set this equal to 0. So I'm going to write my x squared first, then plus 3x. And then combine like terms, you get 3 minus 1 is plus 2. And now you need to subtract your 12 from both sides to make sure you're equal to 0, because you cannot factor unless you're equal to 0. So then 2 minus 12 is negative 10, and now we can factor. So 10, factors of 10 are 5 and 2. Now it's a negative 10, so that means that they need to subtract to get positive 3. That means the 5 must be positive and the 2 is negative. So then we get, for our final answer, positive 2 and negative 5. Okay, there are more to these notes, but we're going to do those later.